day class. My name is Abisoye. I'm a specialist in chemistry. My YouTube channel is KSA Chemistry Tutor. Help us to subscribe, share, like. Today's topic is molecular orbital theory, MOT. In molecular orbital theory, we use this course to determine the strength of a molecule, whether a molecule is paramagnetic or diamagnetic, that is to determine the magnetism of a molecule, and also to know whether a molecule is exist or not, that is whether a molecule is stable or unstable. Now, in molecular orbital theory, we have some terms that we use, such as bond order, we have bonding orbital, then anti-bonding orbital. Let's take a sample. Let's say we have hydrogen plus another hydrogen. This is a molecule. It will give us hydrogen gas, which is H2. Now, if we want to determine whether this molecule is exists or not, we need to separate the molecule into two, the first hydrogen and the second hydrogen. After that, we are going to write the electron configuration of each hydrogen element, which is 1s2, because hydrogen belongs to number 1, then the second one also 1s2. Now, we will now draw the molecular orbital diagram for this molecule, which will be now, each place of this, we call it, this place is called bond orbital, bonding orbital. While the top of it, we call it anti-bonding. Now, to separate the anti-bonding from bonding orbital, we use asterisk to denote the anti-bonding orbital. Now, because hydrogen belongs to S group or S block, we are going to say 1 sigma X bonding orbital, and here will be 1 sigma X anti-bonding orbital. This side is for one hydrogen, and the second side is for second hydrogen that make the hydrogen molecule. Then we are going to indicate that. Then, how many electrons do we have on each hydrogen? We have one electron. So we are going to put that electron here, the first one and the second one. Now, after that, then you are going to share the electron in the orbital. Now, don't forget, an orbital has ability to take maximum of 2 electrons. Therefore, if you have not filled this orbital into with 2 electrons, then you cannot consider the top one, which is anti-bonding. So now let's share the electron here. Then I'm going to spine it, the one of this and the second one here. It means that in molecular orbital diagram of hydrogen molecule, we don't have any electron in anti-bonding orbital. Then let's see whether the molecule is exist or not. If you want to know whether a molecule is exist or not, we are going to use bond order. And bond order, it has a formula to be bond order is equal to total electrons in bond orbital minus anti-bonding orbital divide by 2. Then that means we have 2 electrons in bonding orbital, which is 2, minus what you have in antibonding is 0. Then you say 2 minus 0 divided by 2. Then 2 minus 0, we are going to have 2 divided by 2, and that should be 1. It means that the bond that holds this molecule of hydrogen together is a single bond, and also the molecule is a cis, that is, the molecule is stable. Now, we can also write the electronic configuration for this hydrogen molecule, and that will be 1. You open the brackets by saying, open brackets, 1 sigma x, 1 sigma x. How many electrons do you have in antibonding of sigma x? 1 sigma x, it is 2 electrons. Then if you don't have anything in the second orbital, then you leave it that way. So this is the electron configuration for hydrogen molecule. Now, I want you to remember something. In molecular orbital theory, we have 2 types of molecular orbital theory. We have the one of homonuclear, or we call it homomolecular orbital theory, or we have heteronuclear or heteromolecular orbital theory. All this one, the one of hydrogen is homo, because same kind. The word homo means same. So when you come across the homomolecular or homonuclear orbital, all those ones are like the same elements, like hydrogen molecule, helium molecule, lithium molecule, beryllium molecule, like that. All these one, they falls under homonuclear. So today we are going to look at the hydrogen, helium, lithium, and beryllium. Then before we consider the next one, which is carbon, nitrogen, and oxygen, and all that. Example 2. Now let's look at helium molecule, whether it exists or not, or at least whether it's stable or not. Now, this is helium molecule. Then you separate it, the first helium and the second one. Then you write the electron configuration. That should be 1s2, because helium is number 2, and the second one 1s2. Then you draw the molecular diagram for that, and that one is very simple. Now, the first helium will be here, and the second one will be here. Both of the helium has how many electrons? They have just two electrons. So you place the 2 here by spine them, and you have it this way. This is the first one and the second one, the 2 electrons that we have on top of the X block. Now, you share the electron. Here, we call it what? 1 sigma X, because we have seen this X blocks. Then the second one, we call it what? Antibonding, which is 1 sigma X. You put asterisk or you put star. Then you now share the electrons. One of these will come to this place. Now, this one will have to contain the 2 electrons first. One of this one will come to this side. Then you have already filled this orbital. Then you can now consider the top one. The electron also will come here, and the last one also will come here. So these are the how to share the electron in helium diagram. Then the next thing is that we want to consider maybe the molecule is stable or unstable. Then you have to calculate the bond order, which is bond order is equal to the total electron you have in bonding orbital, which is this is bond orbital, which is 2. 2 minus antibonding, we have 2 there as well, divided by 2. So that should be 0 divided by 2, and your final answer will be 0. It means that the molecule is not exist, or it is unstable. So the molecule, the helium molecule, it is unstable or it is not exist. Then let's find the electronic configuration for this. That should be open brackets 1 sigma X. How many electrons do you have there? You have 2. You consider the antibonding, you also have electron there. That should be 1 sigma X antibonding. How many electrons? You have 2. Then you indicate that this is the electronic configuration for the helium molecule. Now, I want to ask a question. Is this molecule paramagnetic or diamagnetic? Let me use this one to explain that. Whenever you come across the word paramagnetic, that you should determine whether a molecule is paramagnetic. The word paramagnetic, whenever you fill the orbitals with electron and you see the unpaired electron, what do I mean by unpaired electron? If I have just one single electron in an orbital, that is, it is not 2. That particular place, it is unpaired. Then any unpaired electron, it is called paramagnetic. So in helium molecule, we don't have paramagnetic at all because all the orbitals are paired with the electrons. We have two there. So we have only dimagnetic here because whenever you have the electrons that are paired in an orbital, then we call it dimagnetic because it is paired. So that is what we call either a molecule is paramagnetic or dimagnetic. So the helium molecule is dimagnetic in nature, not paramagnetic. Thank you. Let's consider the next one, example 3, which is lithium molecule. Now, this is lithium molecule. We will discover that this one, it will increase from 1s now to 2s, and that should be the first lithium is 1s2. It's number 3. Then after 1s, it is 2x1. Then the second one, 1s2, and you have 2x1. In this place, you have to draw an arrow to indicate the energy level. This is level 1, level 2 of the diagram. So the one of 1x, you first draw that, then before you draw the next diagram of 2x. So this arrow indicates the energy level of the diagram. So now, let me quickly draw the two diagrams. The one of 1x, that will be here. So the one of 2x as well has to follow each other. Now, here will be 1 sigma x. Here will be 1 sigma x antibonding. So the next one is 2. So this will be 2 sigma x. And here will be what? 2 sigma x antibonding. Now, how many electrons do you have in 1s? 1s is 2. The 2 are 2 electrons. Then you put it here. In 2x, 1 is here. And 1 also will be here because we have only 2s1 in the first one and 2s1 in the second one. Then you want to share the electrons. So here you have 2 electrons from both sides, 2 electrons from both sides. So this one is completed. Then you come to the last one. So we have 2 electrons there. So the lower orbital, which is bonding orbital, will contain the total electrons, which is the 2 electrons. So you have nothing in antibonding of 2x of lithium molecule. So how can we calculate the bond order? You can use both diagram to calculate the bond order, or you can also use only 2x. How? Let me first use the total electron in the both diagram. 2 in bonding orbital of 1x, 2 in bonding orbital of 2x, then 2 plus 2, that will be 4 in the bonding orbital. Then in antibonding, I only have 2 electrons in the one of 1x, 1 sigma x. In 2 sigma x antibonding, I don't have anything. That is 2 divided by 2, and that should be 2 divided by 2, and you are going to have 1. It means that this molecule, it is stable. Or you can only use this one to calculate the bond orbital and the bond angle by saying 2 minus 0, because we don't have anything in antibonding here, divide by 2, and that should be 2 divided by 2, which is 1. You're going to get the same answer as well. Now, let's see whether this molecule is paramagnetic or it is dimagnetic. So all the electrons here are paired. So it is not paramagnetic, then it is what? Dimagnetic in nature. So the next thing is that we want to write the electron configuration, and that one is very simple. Let me just do that one on top of this place. So that should be open brackets 1 sigma x. You put the 2 electrons, then 1 sigma x antibonding of that. It has 2 electrons as well, which is this. Then the next one, 2 sigma x, it has 2 electrons. Okay. So in antibonding of 2 sigma x, we don't have anything, so you can leave that one without writing anything. So this is the electron configuration for lithium molecule. So go and do for this one as your assignment, which is beryllium molecule. So you have to state whether the molecule is paramagnetic or diamagnetic, and also whether the molecule is stable or not stable. Thank you.